All right, so I'm not connected. Thank you for telling me right after I start recording. This is going to be a great day. All right, so today's lesson is completing the square. Now, I can tell you this. I've taught this lesson for 5 years, multitude of students. I think I've only had 3 people actually use this method, okay? And I hate the fact we actually have to teach it because I'd rather get a root canal by somebody with Parkinson's disease than actually do this myself. But I've tried to step it out a little bit so it's not as difficult. All right. Now, we have our A, B, and C terms, okay? First thing we need to do, this one's kind of worked out. We subtracted 1 to both sides, and that's how we got here. All right. We have to take half of the B term, or this B term, divide it by 2 and square it. That's why it's called completing the square, okay? And we can do it to both sides because it's an equation. As long as we do it to one side, we'll have to do it to the other, okay? So this right here gives us 16 and 16, okay? Because 8 divided by 2 is 4, 4 squared is 16, yada, yada. All right. Basically, yeah, from here to here, I'm just simplifying the fractions. Okay, now we have to factor this part right here. Well, what are the factors of 16 that add up to 8? Yeah, 4 and 4. So it's basically x plus 4 squared because that's, we'll have x plus 4 and x plus 4. Okay. And over here on this side, we have 9 plus 16, which is 25. Okay. And FYI, we've just got to get through today's lesson and homework, and it's not on the practice test or test. Okay. Or I think maybe one question. No, I don't even think I did that. All right. So now we take the square root of both sides. Okay. And when we do that, this basically just this sounds bad, and I really shouldn't use this analogy, but this makes sense. When you take a square root or something like that, it just kind of rips the roof off, kind of like a tornado. And we have x plus 4 equals, now with this 25, we're actually going to have a positive and a negative 5 because negative 5 times negative 5 is 25 and 5 times 5. And then we actually have to subtract 4. And we get x equals negative 4 plus or minus 5. Now, because 25 was a perfect square, we could actually kind of do this. We're going to have negative 4 plus 5, which is 1, and negative 4 minus 5, which is negative 9. Okay? So I meant to look up where people actually need this. I think there is something up in higher level math. Well, I'm saying higher level like calculus, Cal A, Cal B type thing where you actually need to do this to solve something. But other than that, I think this is super outdated. That's just me personally. So, but we actually have to teach it. So, oh well. All right. Now, so if you've noticed kind of on your notes, it looked like I copied and pasted all the directions on the right-hand side, and I had the blanks for the left-hand side for us to fill in. And a lot of the questions from the homework is some of the stuff from the like putting stuff in order and things like that. It's not actually, it's more conceptual stuff. All right, so right here, if we move the C term over, so that means we had to move 64 over. All right, so 64 is going to go here. And we have to complete the square, so we have to have negative 10 over 2 squared and negative 10 over 2 squared. Okay? Well, negative 10 divided by 2 is negative 5. Yeah, negative 5 squared is 25. Okay, so we got 64 plus 25. All right. And see, this is why I've never understood this, why we had to write it out and then factor it back. I think long ago, back before the internet, when I was actually doing this in school, we just took this term and then wrote it right here because we were going to have 5, because that's how it factors. And then, let's see, 64 plus 25 is 89. All right. So we have x minus 5 equals plus or minus square root of 89. All right. And that's the good thing about these type calculators. There's a way to set them up that it will actually reduce the radicals for you, and you won't get a decimal. So if I took the square root of 89, I actually get the square root of 89. Okay. So I don't want a decimal form. And I like problems like this because it makes life easier. And when we do quadratic formula tomorrow, we'll have some like this, I think. Huh? This is plus or minus. It's written like this. That's where we have the positive version and the negative version. So, and the negative is always applied after the square root. We'll learn about other stuff like that tomorrow. Yeah, super fun. Is this not? No, it's not. But at least I've got it in fill in the blank mode. If y'all were actually having to hand jam all this, wouldn't y'all love to do that? No. I like guided notes like this. I actually have a lot of students that they, even in my higher level math classes, they like on some of the more difficult stuff, they like these guided notes, and it makes more sense to them. I'm like, okay. All right, so move the C term over, so we got to subtract 3. All right. And then this is minus 3 right here. Oh, yep. I did a typo, but it's okay. All right, then we have to take half of 6 and square it and add it to both sides. This is 9. This is 12. That's 9. All right. And this factors out as this, which is the half of the negative 6 anyways. I have x minus 3 equals plus or minus square root of 21. So yeah, not super duper fun, but yes. Tell me when to stop. Okay. So, you know, even when I taught this in Algebra 2, like the old Algebra 2 trig final was when you complete the square, what are you adding to both sides? And that was the only question on the final that dealt with completing the square. So I think there might be a problem like that on your homework. I really can't remember. it's a mystery to everybody. So, if we can we only have 4 problems on our notes, right? Yeah, so we've suffered through 2. We can make it through 2 more. Okay. All right, so we got a 1 right here. And then this. Yeah, I forgot to make an extra space. Oh well. At least there's room. So this is 36. This shouldn't be 5. See, I knew there was typos in here. Should be -6 plus 36. Let me white that out. Don't y'all wish y'all could do that on your papers? Yeah. Eventually, I foresee a time like past this where they actually realize, hey, we can save paper if we use some type of thing like Kami or something like that, where if students have some type of pad like I do and could actually write on their PDF and then turn in notes and stuff like that way. Just save your notes on your Google Drive and turn in homework. That would be awesome. Yeah, the bad thing with iPads, because we used to have a lot of those, after like 3 or 4 years, they're not worth anything. Yeah. Mm-hmm. Well, also you have to think about it. We have just in this school, if everybody at school, there's 2,200 students. There's about 2,200 students at the other high school. There's about 1,800 at both middle schools. We have close to 10,000 students. Yeah, that's a lot of money. All right. 30 goes here. All right. Now, when we take the square root of 30, let's see if that actually reduces. Oh, it doesn't. That's awesome. I thought I actually had one in here that reduces, but I guess I didn't. So used to, we would go over this. It would be like a day 1 where we're solving simple radical equations, and day 2, and they eventually get harder and harder and harder. I took all that crap out and just put what the last final step is, if this is actually completing the square, and put it on y'all's notes for the day. I didn't want to have 45 to 50 minutes of notes today. If that's okay. Is that okay with y'all? I mean, I didn't think y'all would complain. Though that one over there looks like she's very upset that she doesn't have to take notes for longer. Where are you at? This right here? So what I'm doing is I'm subtracting this 6 out right here so it goes away. And this, because I got to do it to both sides, that's why this -6 shows up over here. And I always write the numbers on the outside because now if you try to do some of this stuff in your calculator, it will actually do it like this. Shucks, if I can actually write the freaking sign right. And I don't like writing things like that because a lot of students will forget and they'll not understand that the -6 is not in there. So that's why I never do that part. Yeah. Woohoo! Last one. So 49 goes here. I won't have to widen out. Okay. So we got 14 over 2 squared plus 14 over 2 squared, which is 14 divided by 2 is 7. So we're back with 49. See, this is why this doesn't make sense to me. I mean, we already just had 49. Why are we writing it again? It's negative 41 plus 49. So 7 goes here. 8 goes here. 8. So x 7 equals plus or minus. Now, I do know this one. That's not right. 8 will actually reduce. Okay. If your calculator is set up correctly, you'll get this thing. I don't think y'all could see it. So let me see if I can make this bigger right here. Okay. So it's actually like 2 root 2. And it will do that with your calculator if it's set in the right way. If you're borrowing one of these up here, I'll help you to make sure it's set up the right way. But again, I'm not really worried so much about that at this point in time. Whoops. Undo. Oh, man. I undid too much. So, okay. So, here's the big deal. The main thing I want you to take away from this is that when you take the square root, there's a plus or minus. Okay. Honestly, if you don't do your homework right now with your handout with all the guided notes, you're really hurting yourself because I basically took it stuff straight from there. Okay. Putting things in order and things of that nature and this, that, and the other. But